Hello, Hacksters! Welcome to Friday. We have a new format for you today. We've got David Groom in the house. How's it going, David?
Pretty great. It's Friday.
David is the Yes, Friday. I'm closing out the day with this. David is a community editor at Make Magazine, and it is CircuitPython Day, as is being celebrated by Adafruit with all-day live streams. They've even got a song for it. It's incredible. And to celebrate that, we are going over the new Raspberry Pi Pico 2, which is powered by the RP2350 chip, which neither of us has worked with before. I also haven't actually done a lot with the Pico original or the Pico W, so it's going to be a real adventure. We're going to be actually radically transparent with this. We have a notes page. You can find a bunch of links in the description to this video, but also I'm going to be continuing to take notes, and I'm going to be using these in a project. So similar to my first steps with Arduino Alvik Robot Kit tutorial, which I published recently, after hacking on it with David, I'm going to be taking notes and taking photos in order to publish these later as a full tutorial. So you don't need to follow along with the doc, but you can see me taking notes for the getting started as we go. Let's see. So in the interest of radical transparency, I'm showing you our entire format here. We're going to start out with CircuitPython Day, the Pi Pico 2. We've already gone over the format, and then a little bit about us. And I'm going to show you this debug probe that we also have. So it is CircuitPython Day 2024. If you missed these previous parts of the event, go check those out. We're actually at the same time with a CircuitPython game jam with Tim. This is a very different event, so I figure it's okay to have a little overlap, and you can find the song there. Tag your stuff, CircuitPython Day 2024. I missed that in our tag. Actually, we just put CircuitPython Day, but go check it out. And there's lots of other cool stuff that you can check out with that. We've got the Pico 2 that we're taking a look at. You can find not only the official product page here, it's in the description. The link is in the description to this video. Find out more about the RP2350. You can find a Hackster article on that I've been reading through by Gareth, who is one of our incredible resident writers, covers all kinds of cool stuff, and also the Raspberry Pi official blog about it, which goes in not only to the 2350 chip and the new board, but also the security measures they've been taking onto it, the fact that it's in production through at least January 2040, the multiple variants of this board and of the chip that will be available, different sizes and different capabilities, but also this board itself is pin and format compatible with the prior Pico. Other interesting stuff that we're going to go through. We're going to look at that together. And let's see. And then, oh yeah, the other thing that they sent me personally is this debug probe. So I'm going to make this full size. There we go. So besides the Pico 2 that you can see here, and its little, comes on its little tape reel situation, they also sent me this. I'm not going to cover this in the video, but you can see this other cool product that they are now shipping. Unfortunately, I cannot adjust the brightness on this, so it'll be a little dim right now, but you can see it comes with different types of cables for hooking up to whatever hardware you want to do. And then let's take it out of here so that we can get a little bit better brightness. Here is the probe itself, and we may do a follow-up video covering this specifically, but as you can see, it's for debugging all your good stuff. You've got micro USB on this side, and then a couple of outlets where you can hook up the different cables they sent you. But now, before we dig into the Pico 2, let's introduce ourselves. So, David, would you like to tell us a little bit about yourself?
Sure. I'm David Groom, commonly known online as iShotJR. I'm also hacking on the Pico 2. I was part of the developer program. So this is actually like the original, the Rev A Pico 2. You can tell, I believe, because it's got the Space Invader on it. But I haven't played with CircuitPython on it at all. And I've played with CircuitPython a little bit in general, and MicroPython a little bit in general. But basically, this is just a fun excuse to immerse myself in that a little bit more and figure some of that stuff out together, I think.
Absolutely, and you can find David's profile in the links in the description as well. as well as you've published a bunch of projects on Hackster and won a bunch of awards in the past for different contests, which is super cool, including the Pebble Rocks Boulder
Aw.
contest that we went through. You can find a bunch of my projects too, but I'm always here, so whatever. And I'm gonna just cruise through this real fast. I'm Alex Glow. I'm your usual host here at Hackster.io, and I love doing this kind of stuff. I haven't, the last couple of years, I haven't gotten a ton of chances to actually dig into things beyond the unboxing stage, due to all kinds of different stuff. So I'm really excited. I've also messed around a little bit with CircuitPython, but I haven't done a ton of it. I actually never really got to dig into the original Pico. And so this is my chance to really, like, as I said, radical transparency. And this is definitely a live hack. We're going to be going through it basically from soup to nuts and seeing how we get along with this. So yeah,
So
if you're interested.
I was just gonna say, I hope this is okay to share, but Alex and I have actually been experiencing the problem that she just described, where we get a lot of hardware. There's a lot of stuff we have to review and familiarize ourselves with, and it just literally starts piling up. And so for a couple months now, we've actually been doing these little sessions together where we get a lot of the same hardware that we need to familiarize ourselves with and play with and figure out and do projects with. And so we've been doing little co-hacking sessions, and we've always talked about kind of live streaming them because I think they're pretty interesting and informative. And so this is kind of the first instance of that being streamed, I guess.
Yeah, and I was personally a little nervous about it because I'm like, but what when it's like I'm figuring stuff out live, it's not as clean and professional. This is the space for that. This is the space where we get to be like beginners, and I'm terrified and excited. So without further ado, let's pull this out of the container. For me, anyway, you've already got yours out of the container, but I'm gonna pull it out of the little thing here. I've got my little micro USB cable plugged in. This does have a micro USB connection, as with the Pico, the original Pico. So this is for backwards compatibility. Let's take a quick look at the board actually before we plug it in. So here we go. You've got, I believe, 26 GPIOs. I will fact check that. But this is the new 2350 RP2350 chip on here. And let's take a quick look at a couple of articles because that's going to be a good way to introduce ourselves with it. So I've got the official Raspberry Pi article pulled up here, as I mentioned, and let's just scroll down to the specs because you can read about all this other interesting stuff about like why they made the decisions that they made, upgrades from the original Pico. But yeah, you've got 250 megahertz upgraded from ARM Cortex M0 to M33 cores. You've got almost double the on-chip SRAM static RAM, and then you've also got two where is it? Two RISC-V cores that are Hazard 3 cores that you can use either in like 1 and 1 of each, like one ARM core, one RISC-V core, or you can use 2 of each at the same time, or like 2 matched ones at the same time, or 1 of each. There's a lot of new security features so that you can go from a prototype to a full-blown product with this, including ARM Trust Zone. You've got signed boot support, etc. SHA-256 acceleration, and a true hardware random number generator, which is kind of cool in my opinion. Even as someone who does occasional like music stuff, you know, I've worked with Sonic Pi in the past, and that has a very, very simple like random thing where it's actually just a sequence that repeats every time, and then there's other ones that like that are supposedly more random on other things, but this has an actual RNG on it, which is pretty cool.
Another thing I wanted to point out that's interesting about the RP2350 is there are different packages available.
Yes.
So the Pico obviously has the specs that you mentioned, but there are other variants. There's one that has many more GPIOs, the B, as it says, they have 48 GPIOs if you need more GPIO, which I think is pretty interesting.
Super cool. And you can read all about those on the official Raspberry Pi blog post. They've got the product page as well, and you can participate in the samples program that way. Then you've got 4 megs of external QSPI flash on the board here, but also I think you've got capability for up to 16 megs on the chip itself. And then, yeah, they'll be offering this in production up to at least January 2040, according to the article. And then also something really fun. So you can program it in C and C++. You can program it in MicroPython and CircuitPython. We'll be using CircuitPython today because it is CircuitPython Day. But also they're looking to bring Rust to it, which I think is pretty cool. And let's see, is there anything else that I thought was especially cool on here?
Oh, the pigweed is interesting that you just scrolled past as well. Google pigweed.
Oh, this. Yeah, what is this? You've got the debug.
I haven't played with it for several years. I was surprised to learn it was still a thing, but I just thought that was pretty interesting. I played there was like a conference or something that I think it was in the 2019 ARM AIoT. There was a pigweed workshop. I don't remember a ton about it. I just remember it being kind of interesting, the way that it was like, embedded programming, but like as if you were a node programmer with like package management and stuff like that, and things like that is less common in things like CircuitPython and MicroPython, although that's starting to change. Yeah,
cool. And I haven't actually gotten all the way through this. This is the end of the week, etc. No excuses, whatever. Ooh, $10,000 bounty for the first confirmed break of their signed boot process. They are serious about the security thing. That's incredible. So yeah, they did power this year's DEF CON badge, which apparently has had some drama. I know nothing about it. I'm not going to go into it. That's for another day. But yeah, go check it out. And you can read the rest of the article. But I would like to get down to the hacking. I think we're both excited about that. Let me see if there's anything we missed before that. Okay, yeah. So we're talking about CircuitPython. It's CircuitPython Day. We've got a .uf2 file for the Pico 2. I, as you saw, just took mine out of the container. So I've got Mu loaded up, which is what Adafruit recommends for doing CircuitPython on different boards. David, I think you're working in Visual Studio. Did you say VS Code?
No, I said I tried to open Visual Studio and it couldn't handle the live streaming and Visual Studio at the same time. So I've also switched to Mu as well.
So we're going to be doing Mu. Sweet.
Yeah.
So the first thing I need to do is plug this in. Diddly-doo.
And just to give you an idea of how bad I am at the embedded Python, the first thing I did was open the MicroPython lab for Arduino. And I was like,
oh, yeah.
No, wait,
well, we've been working with that for the Alvik kit.
Yeah.
So, any flashing lights? Nothing yet. Interesting.
Nothing yet.
I wonder if I did something wrong or if that's just how it is.
Did you drag you've installed CircuitPython?
No, I've done nothing on the computer yet. I literally just plugged it in. So we'll see if that happens when I install that. I'm going to switch to that. Here we go.
Yeah, there's no indication of power or anything.
No, yeah, that's kind of surprising.
Yeah.
Let's see what happens when I drag. So I downloaded this .uf2 file from that page, and I'm going to drag it onto, okay, yeah, it has shown up in my Finder. And I'm going to show, not my whole screen. But I'll see if I can show a little bit more. We'll stick to this. Okay. .uf2 file, dragging it onto the RP2350 device that has appeared in my Mac Finder. And it says it is copying. And the board has restarted. So I got your usual Mac eject the thing. It didn't eject properly, which it does whenever you have a microcontroller plugged in, and it gets mad that you let it reboot without without ejecting it manually. And I am going to actually show people my screen here, as terrifying as it is, because this will be really useful. So share screen. I believe it is screen 2, but we'll see. Nope. Pardon me for a moment while I figure this out.
The LED's blinking, so that's interesting. Maybe while you're working on that, we didn't necessarily touch on kind of CircuitPython and what it is and what its relevance is and things like that. So
yeah,
I could kill some time with that if you're still getting that working. Oh, there you go. But
the interesting part is it's not showing Mu at all. It's showing only my browser. I'm very curious. So anyway, please feel free to go into CircuitPython, and I will work on this.
Yeah, I was just so traditionally or originally or typically with the Pico and also with other kind of embedded devices, most development historically has been in C, C++, and so that's a little inaccessible for some people, I think. And so I think a huge part of CircuitPython, the impetus from Adafruit was trying to make all of this stuff more accessible because Python is a pretty easy to learn language, pretty easy to understand. You don't have to deal with a bunch of semicolons and things like that. And it tends to be pretty intuitive for people. So I think a big part of Adafruit's idea was that they wanted to really open their boards up to be something that you didn't have to have sort of old school embedded programming experience in order to use. And we're seeing that with Arduino 2 with MicroPython support on a lot of their new products. And the Pico original and then the new Pico are both really strong candidates for CircuitPython. So I think it's a really interesting and inexpensive way to get started with it.
That's really cool. Yeah, you mentioned the Arduino MicroPython lab, which is something that we've played around with, as I mentioned before, for the Alvik.
Yeah.
Now, I'm sorry, but I'm having a little trouble with the screen going on here. Okay,
No
there
problem.
we go.
There
We've
we
got this
go.
back. That's good. But it won't let me show you the Moo editor, which is very strange, actually. That's not a tech issue I anticipated having, even when I have the entire browser enabled, or the entire like computer screen enabled. But we have this notes file that we can dump into here what we're doing. So I'm gonna show us the screen again real quick. Do I have? I do not seem to have a blinking LED, which is something. Oh no! Here we go.
No,
It is
I
going.
saw it blink a couple times while you were, yeah.
Sweet. Did you see that happen before I put the UF2 file on there, or is that new?
No. Only once you put CircuitPython on it, yeah.
Cool. That's very
And it's
exciting.
very occasional. It's like every 6 seconds or something. It's not like a real obvious blink.
Yeah, no. So I'm gonna go and see if I can. One of the things I love about MicroPython and CircuitPython is that your code is stored on the board in a very readable fashion. You can just look at it like a flash device and take a look at the code that's on there. So I'm going to go and do something I usually do, which is copy everything that's on here and just dump it into a folder in my project folder. So I'm going to say Pico 2 original files and take everything that was in that device and dump it into there, including some hidden files before I change anything, so that way I can hopefully get back to a working state if anything goes wrong. I'm going to try one more time to share my entire video screen because I don't want to have to be keep switching on you. Allow. It's really not even showing Finder. This is very strange to me. Unfortunately. I apologize. But it's cool to see some familiar faces in here. Hello, Robert. And hello, Tariq. So we will, I am well. And David, how are you doing?
How am I doing?
Yeah.
I'm also, I've got my CircuitPython all installed and my Mu open and waiting for their excitement.
Let's make the excitement happen. I'm going to take a look at the code Pi file that's in here. I'm just going to open that up. And all it says is print hello world. So I'm going to go into my Mu editor and you know what? I'm going to go ahead and change to see if I can directly share that. Here we go. It will not share it. I'm so mad. This is really strange. Wow, I'm sorry. But anyway, I'm going to make the Mu editor connect to it. David, are you able to share your screen?
Not easily. I can get to the point where I can do that. Maybe I'm just a little nervous to do that because my system is just kind of not not particularly stable, and I'm
Yeah,
trying not to open a ton of stuff and live stream at the same time. So
that makes sense. Yeah.
I'm not sure
So
if
let
that
me
would
see if I
work.
can hook this up and get it to connect.
Yeah.
Sorry, everyone. There is an element of chaos to this, but usually the chaos is not my screen share will not show the thing I want it to show. So that is very frustrating.
If we just want to look at the code, would it be possible just to drop the code into something else and then copy it back and forth? Or I'm trying to.
Yeah. Let me see what I can do about that. I can definitely just copy this file I've got going, the file from the board into my browser. So this is the entire contents of the code.py file. Now, it's been a while since I did anything with CircuitPython. So when we're working with this board, do you know if there's something we have to hit in order to make the editor see it?
The editor see it? I think you just load it from the board, don't you?
The Mu editor in order to get it to connect.
Good point. So I opened mine and I already have a REPL, but I'm not sure, I guess, if the REPL is on the device.
Oh yeah, actually it is working on here.
Yeah, I just hit serial and it opened.
I wonder if it's a different editor, maybe Thawny I was thinking of, where you have to tell it what board to connect to. And definitely the Arduino one, you usually have to tell it what board, but it actually does seem to have straight up printed that code.py output hello world done running, and I'm gonna copy the little startup message in here. This is exactly what it said. And I missed it because I thought it was just like the REPL's hello thing.
You're sharing your downward cam right now.
Oh, apologies. Yeah, my screen
referring to
share
the
is
document.
deciding to completely bug out on me, and it's not totally failed. I'm gonna do something weird and try to save the rest of the session by switching to Chrome and see if that will solve my problems with screen sharing. It's very odd to me that it started out working and henceforth thereafter decided to fail. I looked this up before and it was an actual issue in Firefox, but it seemed to have fixed itself. It's like a Firefox StreamYard issue. And I'm glad I put chaos in the description for this thing, because it absolutely is.
So you're not able to share anything right now? Okay, looks like we lost Alex.
And I'm here. I'm trying to switch to Chrome.
Okay.
And I'm afraid to close this, but I'm going to close it.
Okay. Are you still there, Alex? Looks like no. Then I guess I'll take over for a while and perhaps waffle on about CircuitPython some more. So I have used CircuitPython in a couple projects. I used it with the Arduino Nano RP2040, I believe. And I really started to enjoy it because it allows for a really quick iteration loop. You can write code and run code kind of instantly, as opposed to the traditional Arduino or any other compiled language situation where you are
fake me in here who's being a ghost, and I cannot screen share, so that's really fun. I think at this point I'm not able to screen share. I can't show people my IDE or our files or anything in my browser. I hate to say it, but I think that this might be a time when we should come back and do this another time, because it is not like some of the basic elements are failing on me. That is not something I anticipated happening today, and I apologize very much, because I know you got lots of stuff going on in your day. And everyone, I really want to appreciate you coming out for this. What do you think, David?
Well, let me try. I'm nervous about sharing mine just because my computer started to croak as I did Visual Studio. But let me just try. If I just share one window, how hard could it be? Let me just see if I can share my mu, and
Yes, we're gonna try and push on through.
all right,
We
let
got
me
a
just
couple
set
more
some
tricks up
things
our
up
sleeve.
here.
I can bring this
Okay.
back.
So
That's not gone forever.
let's see. Share screen. Okay, I want to share my mu window.
I
Mu.
might be able to
Okay.
share mute too now. Come on.
Oh, really?
Maybe. No, it
So I
told me
think.
it's sharing, but it's not actually sharing it.
Okay, so is mine sharing, or is it just mu like impossible to share?
There we go.
Okay.
Cool.
All right.
Awesome. Yay.
Okay.
Oh,
So
sweet. All right. So if
we've
we do
got
the
a
same
solution.
thing, I can show my device and you can show your editor.
Yeah. Perfect. Okay.
I love
No
it.
problem. Okay.
Hackster Live, everybody. Live hacks. Chaos time.
So
Friday afternoon.
my first question is, in opening the serial monitor,
Yeah.
is that really the device? And how did it know what COM port to use? It didn't ask
That's
me.
what I was saying. I was
Like, is
like,
this
usually
real?
you have to tell it what device it's seeing, but this time I didn't have to do that. And usually I thought in the bottom right in this, I might be thinking of Thani here, but I thought in the bottom right there was a thing where you choose what device to talk to. But I think I'm thinking of Thani because that's the one where you use it for like the microbit and stuff. And so you have to tell it that it's talking to a microbit. But this is so if you look in CircuitPython at the top left, you can tell it what mode it's in. And there are different ones. There's like, Python 3, Pygame 0, there is ESP MicroPython, and there is BBC microbit. So maybe that's just like what I was thinking of. If you click on top left on the mode
Interesting.
button.
So I'm looking at the select mode thing.
Oh
Right now
yeah.
I've got a little Python right here, and I'm like mousing over it, but that pop-up is not showing.
Fun. Well, there we go.
So,
Let's try some code.
all right.
By the way, y'all, I'm sitting on a yoga ball, so that's why I'm like bouncing. So there is, I dumped in the shared document here a link to the, there's some MicroPython or CircuitPython code examples. Oh no, they're Pico MicroPython examples in GitHub from Raspberry Pi, and you can find those. Now, there are some differences between MicroPython and CircuitPython. CircuitPython is Adafruit's custom fork of MicroPython. So there are some differences, and I'm not super familiar with what exactly those differences are. And I'm not sure if you are either,
well,
David.
we're gonna find out. I know.
Yeah.
I believe that CircuitPython is like a fork of MicroPython, and that
It
it
is.
doesn't contribute back to MicroPython. So they have forked and bifurcated. And in my experience, CircuitPython obviously has fantastic support for Adafruit boards, and is really kind of focused on the beginning maker. And then MicroPython seems to have some of the features that I was looking for that I didn't find in CircuitPython.
Yeah.
So I remember I was like, when I was first playing with whichever Python it was, I think it was CircuitPython first, and I was like, oh, cool, how do I do interrupts? And the answer was, there's no interrupts. You can't do interrupts. There's a different way. There's like async where you can do it in CircuitPython, but we don't have interrupts right now. Maybe that's changed since I tried it several years ago. Whereas MicroPython did have interrupts, so they're quite different. Where
really
am I grabbing?
interesting.
Where was the code?
So in the comments, actually, I dumped in. There's another repo I found that is Pi Moroni's Pico CircuitPython examples. And so if those work on the original Pico, I believe they should work on the Pico 2 as well. They've done a lot to make sure that the two are compatible.
I have not been looking at the chat this whole time, so that's good.
That's chill. There hasn't been a lot going on. We got a beautiful sweet note from Ayesha. Hey, how's it going? Who says she still had fun, and that's when everything was broken. Everything's still broken, but we're plowing on anyway. Also, there's circuitpython.org/libraries, which I will dump in the chat as well. Here we go.
So the Pimoroni ones seem to be specific to their boards. I see Badger 2040, Motor 2040, Pleasant 2040.
We've also got a welcome to CircuitPython Adafruit thing that's linked in the bottom of that page.
Give me that. Where's that? Yeah.
It's in chat now.
All right. Let's start there. That
So we've
sounds
installed the
good.
Mu editor, we've installed CircuitPython. If you look in the left-hand side of the page, there's
Yep.
all kinds of info.
Connecting to the serial console. Okay, so that worked. Yeah. Are
Yeah,
you
and now I'm
using
kind
Mu?
of
Yeah.
curious, should it have renamed the
Okay.
drive to CircuitPy? Did it not do that because I didn't do hold down the boot button while plugging in the board? I didn't push reset to go into DFU mode, so maybe it didn't actually. But it said it was downloading the UF2 file, so I
I
guess we'll
didn't
find out.
either, and I'm able to view the files on the device,
Me
and
too.
it's called CircuitPy. And let's see
And
if it
Mu
works.
is
So
showing, like actually, let me see. I'm gonna load. Yeah. Oh, the drive is called CircuitPy now.
cool.
I guess at some point it changed itself on me. Okay, cool. Yeah, it's
So I'm
I
reading
hit
the
the load button in the
documentation.
editor.
I'm reading the documentation. It says, "Are you using Mu? If so, good news. The serial console is built into Mu and will auto detect your board, making using the serial console really, really easy." So we
Gotcha.
were just suspicious. We were like, "It can't be this
It
easy."
can't be that easy.
It is that easy.
It has to
Awesome.
be hard. Instead,
All
all the
right.
hardness is coming out in the like video problems, but whatever.
Okay.
So, so let's see. I'm reading through the Welcome to CircuitPython guide here.
Yeah.
We've already connected to the serial console. We can scroll down.
Give me some
There's the
code. Give me
REPL.
some code.
Give us some like basic stuff
Welcome to the
here.
community. How to do pull requests. Come on. How do I
CircuitPython
do
Essentials.
blink an LED, guys? CircuitPython documentation.
Here's the Essentials guide. I'm dropping in the chat as well. Doodly doo doo doo. Pins and modules, built-ins, digital I/O. There is a built-in RGB LED, so I'm going to scroll down to that. Every board has a built-in RGB LED. You can use CircuitPython to control the color and brightness of this LED. Now, this one I don't think has an RGB
I'm not
LED.
sure
It
that's
seems
true
to
for
have
the
that.
Pico. The Pico just has the green, doesn't
Yeah,
it?
no, yeah. It is a Raspberry Pi board, though, and not an Adafruit one.
Mm-hmm.
Let's see. What about just like a regular... I'm going to say Pi Pico CircuitPython blink in my browser. Oh, getting started with Raspberry Pi Pico and CircuitPython. Beautiful. And it talks about the built-in LED. Okay, we got there. This is
Right.
the exact type of process that I go through when working with a new board is like open a million tabs with documentation until you find the one that you are looking for. And to be realistic, I leave the rest of the tabs open at the same time as well, because what if I need them later? But you know, that's a personal malfunction. And let's go back to your editor. Actually, you know, yeah, let's do that. So we're going to do the same things in our editor, and we're going to take a look simultaneously at my board, which I might go in a little closer on so we can see what's going on.
All right. So the theory is if I hit save on this, it's going to run, right?
Yes, it should. That with MicroPython at least, and I believe CircuitPython also, what happens is as soon as you save it, it will run. I'm going to fix my focus here so we can have a nice up-close look at what happens when I do the same thing. So here we go. It's as close as we can get. Pardon
Well, I
me.
saved it. I don't have a blinking LED.
You just copied what was in the guide?
Yeah, you can see my
Oh yeah,
share.
except for the comments. I probably don't need to put the comments in, but I'm going to do
Oh
it
yeah, I
anyway.
didn't bother with the comments.
Save. So when I pasted the stuff into the editor, there was a little red indicator next to code.py that now has gone away when I hit save. And now, okay, so wait a minute. Is that save just save a file, or is it? No, it's literally opened the file from the board, so it should be on there.
So when I hit save, it says it saved it to fcode.py, and
yeah, and I look at
fcode.py is the CircuitPython.
And I look at the
drive.
board in my Finder, which is my file directory, and it does show that the file was just updated. Now, what is the interval that it's blinking at? It says, oh, while true
It's just
LED
turning
value is
on.
true. That's supposed to just turn it on.
Yeah.
Sometimes they're a little backwards. What happens if I put false? So that's not even blinking.
Mm-hmm.
What happens if I hit save and then say false? Does it turn it on? Not yet. I'm going to try saving it again. Okay, I'm gonna try outside of the editor, just opening code.py in a separate thing, and it has updated it, so I can confirm that the save on the editor is corresponding to the save on the board. Now, I wonder if this LED doesn't have a name that corresponds to the one that's in. Well, no, it is the Pico example. It should be the same. Turns on the built-in LED. Is there a library we need? Import board, import digital I/O. Let's see. There's a lib file in the directory on the CircuitPy directory. It's on the board.
Okay.
I would have assumed that digital I/O would be like a built-in one and board would be a built-in one, but let me check about and see if there's a way to like download that.
Yeah. There's a little thing that says download project bundle at the top. I'm going to do that
Oh
because
yeah, yeah.
I
Let's
bet
hit
we're
that.
missing libraries, like you said.
This is actually awesome. I'm really enjoying this. Built-in
Yeah,
LED
I mean,
on.
we want it to be radically transparent, and I think we've been
Yeah.
pretty open about.
Now this one, I don't see any libraries in here, but let's see. There's a README. So this bundle contains 2 folders, one for each of the latest versions of CircuitPython.
All right, how do we know which version we just downloaded? Was it 9?
I'm gonna assume it was 9 because I just reinstalled Mu, and I just downloaded the CircuitPython UF2 file. So I'm gonna assume that we have the latest one. To use this
And my file is
project
actually.
bundle, copy the contents of the Python version folder you're using from the zip. The contents of the folder. So you find the version you're using, go into that folder, copy the contents onto your CircuitPython drive. Contents include the code.py file, the lib folder, and all of its contents, including subfolders and .mpy or .py files, and any assets such as images, sounds, etc. This will replace the current code.py and the lib folder and its contents, so back it up before you copy these files. The weird thing is that, yeah, it doesn't seem to have included any lib folder, which I assume means that those libraries are built in and we don't need to download any new ones, which was my only working theory on why this LED is not blinking. So let's see if I can find a new Pico 2 CircuitPython. And my backup plan here is that Adafruit's been doing this CircuitPython Day thing all day, and I'm pretty sure they had some Pico 2 contents.
I was going to say, my backup plan is I also have a regular Pico, so maybe I'll try that.
Oh, I do too! We could always mess with that.
Yeah. I'm going to switch.
Yeah, so we could switch and then watch the Adafruit content later on and see if, because this board just came out and CircuitPython Day is today, so you know we could mess around with this. Let's see. So Pico 2 download. I don't know if anyone's got a guide for Pico 2 and CircuitPython yet, except for like what they were just doing today. So I could be wrong. Could be wrong. The Raspberry Pi official stuff mostly mentions MicroPython and C and C++. Yeah. Okay, should we mess around with the Pico? I also want to point out that while I was looking at this stuff, there was a really cool article I read about PIO by the Blues team, Rob Lauer specifically, and I'm going to drop that in the comments as well because that's something that's taken me a while to wrap my head around, and I'm still not sure that I've totally got it. Because what I thought while I was reading about PIO was, oh, this kind of reminds me of FPGAs. And then I started, like, I literally looked up, like, PIO versus FPGA, and people are like, no, it's not the same thing at all! And I'm like, okay, well, I guess it's not the same thing. But, so I'm interested in delving into that a little bit more. But I will put in the description to this video this article from Blues by Rob Lauer that's all about the difference between, or about PIO in general and how to use it and why to use it, and elsewhere we can read about why it's not like an FPGA. The reason I thought that it was, for people who haven't themselves delved into this at all, is that a big part of why you would use PIO in the first place, which was a huge selling point of the first Pico and also this current one, is that you can, for example, if you want, you have two UART, 2 SPI, and 2 I2C options on the Pico as is. And if you want more you would be able to reassign pins to create more UARTs, to create more SPI, to create more I2C options for yourself so that you can connect more stuff to it. And to me, I was like, oh, well, that sounds like an FPGA, but it's not. I'll figure it out and we'll come back. But yeah. Oh, yeah. Thanks for joining us. Yeah, the video tech is definitely giving us some trouble, but we're plowing a lot ahead anyway, as you will see. What do we got? We got a comment from Hector as well, or Hector. I said I had to wait until after my move to order a Pico 2, but so glad there's stuff going on about it. Gonna tinker a Pi 5 IR cam along with you. Oh yeah, we've got a Pi 5 coming around. I think we're gonna do some of the AI stuff as well. So what do you think, David? Should we call it and move to the original Pico, or should we?
So I've got my Pico. I just flashed it with CircuitPython. For some reason, Mew is saying could not find attached CircuitPython device, even though I'm looking at it and it's got code.py
Weird.
on it. I'm not sure what
In
Mew's
your
problem
file
is.
directory on your computer, are you what OS are you running, by the way?
Windows 11.
So file manager, of course, for those following along. Is it showing up as a drive called CircuitPy, or?
Yeah, CircuitPy is my F drive. I'm just gonna try closing this one and reopening it in case it's something weird.
Okay, so I'm also going to go to the page that I'm dumping in the comments here. The CircuitPython option for Raspberry Pi Pico. And I'm going to drop it on. I'm going to swap my little boards out here. So we've got the Pico 2. We haven't been able to get the LED blinking. We didn't find any library issues that would be causing that. So I'm at least gonna go back and watch some of Adafruit's CircuitPython Day content that's you can find in the description to this video. It's linked in there, and come back and try and give this another shot. And we'll definitely have an update for you another time. But for now, we're both swapping back to the original Pico, and we're gonna spend the rest of our time having a look to see if we can get this little. Oh, we've got an LED on. That also happened with the original one. I've definitely plugged this in before. I made some kind of horrible breakout for it where I was connecting it to a bunch of buttons for some unremembered mystery terrible project. But yeah, so who knows what's on here. The nice thing is that we can find out. That's what I love about these MicroPython, CircuitPython boards. We've got code.py in here. What is it doing?
Okay, so I think that
Let's keep this
LED
up.
code maybe was just not functional.
Yeah.
Because if you can see my screen, my
Ooh.
Mew, so I loaded the same code. Nothing happened in terms of LED. It's just seems like it's not working all. So then I just added the print line too, and that's clearly running. So this LED is just not happening.
That's so strange. So since it's happening to both of us, I'm going to assume that it's not the LED, like the hardware issue. So it must therefore probably be like a software thing. And I wonder if we can just find out what pin the LED is on. I'm not ready to give up. I'm going to plug it back in. I'm going to try and see if we can figure out what the LED is called.
Yeah.
I'm going to look at this older example that I have that I think interacts with the LED as well. Let's see. And oh, one cool thing about this is that when I swap out the board, Moo instantly loads the code.py file that was on it because I've got code.py open. So when I unplug the Pico 2 and plug in the Pico and vice versa, it like updates that file to show what's actually on the current board instantly. I'm gonna do it again just to have a look. Oh no, I lied. It just never I lied. I was looking at it in the file directory.
So it seems like by adding that while loop, I've like flooded the serial, and my Mew is no longer responsive.
Oh no!
Because I just have a print with like no delay or anything, so it's just like spamming the serial, I think. So I'll see if I can get this back. But
I'm saving this old code.py file from the original Pico, whose LED is on, and I'm going to see if I can turn that one off. On the original Pico and see if that same code dies. Okay, so like, if it works on the original one,
Yeah.
can I get it to work on the new one?
Oh my goodness. I'm desperately trying to remove this line of code. It's not letting me.
I'm overriding the original one. And the LED turned off. Okay. So what I've done here is that I took the code.py file that was on this original Pico. And it also had the line where the LED was, while true, the LED is on, which basically means, 100% of the time, because while, let me see what it actually says. While, oh no, it doesn't have a while on it. It just says to turn it off. But then if I turn it to true again, and then I save this, after a moment, it should turn on again when it saves the code. So I wonder what happens if I just take out. I'm also going to copy the whatever libraries were on this one and move those to the new one. Let's see what we got on here. Adafruit HID library. I think that is just for keyboard and mouse stuff, but I'm going to copy it anyway.
So
Eliminate all
difference?
variables so that I put the exact same stuff on both boards and see if it'll work.
So can you paste your working LED code into the shared doc?
Yeah, so the working LED code is this like huge pile of code that was for doing a keyboard with the old one, and I will put in the doc, but I'm also going to strip it down and see if I can. I put it way in the bottom of the doc, so I'm saving this to my computer as, let's see.
I see it. Okay, yeah.
Go
to the Pico keyboard. Got it.
Pico orig HID code.py. Okay. Now I'm going to take this old code and I'm going to strip it down to just the LED part and see if I can mess with that. If you see anything before I get this done, let me know.
Yeah, so I'm just trying to get my board to come back at all. It's stuck in a while loop, I think.
Curses.
So I'm going to try and manually edit the code. Yeah. All right, let's get rid of the. In fact, let's get rid of the while.
This code did not throw an error. All it's got right now is import time, import board from digital.io, import digital in out direction and pull. So you're importing some stuff, and then it says LED. It like mounts the LED or oh my goodness, is it what declares the LED, instantiates the LED, it creates the LED in the code. It says LED equals digital in out board.led. Yeah, digital in out is from digital.io, and is that an actual library on the board? I don't think so. No, that's not part of Adafruit HID as far as I can tell. But now I've got that. Okay. And then if I change it to false, okay, so save this to the board. Oh, you know what? Doesn't seem to have worked because the LED is not going to true. Oh, pardon me. So, but I will take this same exact code with the same exact libraries and try to upload it on the new Pico 2 and see if we can whittle it down from there. Because I'm pretty sure that as soon as this loads, it's going to turn on again. Yeah, okay. I'm going to try this exact thing. Same code, same libraries on the Pico 2, and maybe it'll hate me, but maybe it won't. We'll see. Unplug you. My computer's going to get mad. Another interesting side note is that every time I plug in the Pico 2, my computer tries to detect it as a keyboard. Even though it doesn't have the keyboard HID library on it. I think that's not unusual, though. It's definitely possible to make keyboards with these. And take my fingies off of the GPIO. So, of course, we already knew the LED worked anyway because it does a little blinky thing when it turns on, and it was on for a while before we tried uploading any code. So now I'm going to try dropping the libraries from the old Pico onto this guy in the lib folder, which there was only one anyway. Adafruit HID. Drop it into there. Okay. That's taking a second, and now it's done. Cool. And now I'm going to update the code.py on there. And I'm going to, actually outside of the editor, I'm going to copy over the old PicoPad keyboard code, which seemed able to control the LED on the old one. The LED is currently off, so I'm going to save this to the device. And we've got an indication of saving, which is cool. It did blink.
Hey.
That's not what it's supposed to do, but it's
No.
doing a thing. Come on.
Was that just some kind of
What?
indication
Is it
that
supposed to
loaded?
blink? Wait, is this something that's
What?
later on in the code? Switch state while true for button and range, blah, 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 blah. There's no buttons happening. There's a time.sleep between the loop, which is the while true statement. So I would expect it to do something if it had a button attached. But let me take a look more closely through this and see if it has anything that would actually cause it to flash. It definitely talks to the LED. LED value is true is the first thing that it does with it. And then later on, it's also possible there's something embedded in the keyboard library or whatever that would cause it to do that. But if you're automatically setting it to true when you start it up, then that shouldn't be affecting it. Switches, pins, digital in out. Got pull-ups on the buttons. I wish I could show you all exactly what's going on here. It's kind of sad to me that I'm going to try one more time to show you what's going on my screen. It will not let me. Tragic. Okay. Yeah, if there's button switching state or not. It doesn't seem to do anything with the LED except for turn it on at the start. I'm going to do a find just in case I'm missing something somehow. LED, LED, LED. No, that's all there is. It doesn't talk to it. Why is it flashing? Okay, so in part A, we're trying to make it flash, and it does nothing. This code only turns it on, and it's flashing. David!
I don't.
What? Next time we should have a sacrificial lamb from the Adafruit team, and by sacrificial lamb I mean a friend, a cool, nice friend that we know, a cool, nice, smart person from the Adafruit team to help us with this, because I think that, like, you know, that would be a cool upgrade. Is like, if we get stuck on something ridiculous like this, we could pull the like eject lever and be like, hey. Or like hit that button and be like, hey, can you help us here, because we are like stumbling around like toddlers.
Yeah, I have the same LED code from your the document there, and it's just nothing's happening.
Is that
and
the original one or the 2?
This is I went back to the original Pico on this one. Nothing.
Is the LED on?
No. But I've got a loop going with my hello, but now I've got a delay of half a second each time. So
I'm gonna try just like a really basic LED thing. So I'm gonna keep everything with all the import statements and stuff, and then I'm gonna try removing all this stuff about switches. Just like go away, and keep the true while true loop, and keep the little time.sleep in there. It's gonna be what? Well, that's clearly like a. I think it's seconds. I think time.sleep is in seconds, not milliseconds, because it's 0.01.
Yeah.
So I'm going to say 0.5. And that's not going to be a debounce. That's just going to be a blink rate. Okay, I'm going to take all this stuff out. And presumably there is like a... Presumably there is a... What am I trying to say here? Oh yeah, just like LED.value not like to like the opposite. Okay, so equals exclamation point LED dot value. Can you do that in Python?
Are you trying to say you're trying to toggle it, like invert it?
Yeah.
Yeah, it's
I'm
worth a
gonna
try.
drop
I'm not
this in the
sure of the
comments,
syntax,
just like
but I think
someone tell me if I'm totally screwing this up here.
yeah, I
Because I'm
just
a baby programmer. I never went to school for this. I'm literally just saying, "Oh, that looks horrible" in the comments.
well, if
But
you
I'm
look,
just trying to say,
I
like,
shared my Mu again, and I think I'm
"Oh,
doing kind of the same
yay!
idea as you. Like I've
Oh,
just
and
got it
you're adding a
printing
print
like
statement.
the
Fancy."
LED is true. Like, come
Yeah, we're doing the
on.
same thing.
Yeah,
Uh, oh yeah, I'm just putting it so that like you say, so that's like a one-time thing, right? If you put LED dot value equals exclamation point LED dot value,
right.
right? Shouldn't it switch every time?
Yeah,
Or is
yeah,
that
that's
like
right.
in C and not
It's definitely in C. I don't know if you can
is it in
invert
Python?
if it's like a not in
No
this.
clue. Print. I'm gonna
Syntax
add that
error.
same print. Oh, okay, yeah. I'm sure we're wrong. Okay.
Circuit Python not.
Yeah. How do we do this? Because that's how you do it in Arduino, not operator in Python, Boolean logic, Python. Oh, you just say not. A equals true, print, and then in parentheses,
Oh,
not A.
the word not, of course.
Cool. So LED
All
value
right.
equals parenthesis open, not
Okay.
LED value
All right. Look at my
close
output.
parenthesis.
So it's blinking the LED. It's
Is it doing it?
blinking the physical LED. Like it's no. I mean, the LED is not doing anything. But I'm saying if you
Okay.
look at my serial output, like look at the
Oh yeah,
serial
yeah, yeah,
output.
yeah.
Oh, the LED is false. The LED is true. Like what?
Mine is still just blinking its little dance here, like doing its
Every
little blip
little
blip,
while.
even though I hit save.
All right. Can you? Let me copy this code into the
Why is
shared
this the video
document.
everyone watches? I think it honestly is really fun though. So I'm having a ton of fun. So
Okay, I just dropped my code into the shared document, kind of under the
cool.
notes. Can you try running my code and let me know what happens
Yeah, sure.
on yours?
So you got import time, import board, import digital. Oh, that's commented.
And like, I've got two
True.
different ways of doing the LED that are like absolutely identical there. It's just one was the way the original example was, one was the way that your example was in your code that seemed like it was working maybe. And so I just switched to your kind of
Maybe I'll
declaration
make a
style for a
little.
second.
I will absolutely do that in a second. But real quick, I want to just assign it to a variable. Let me say like A equals LED dot value, and then say LED dot value equals not A. Let's see if adding like an extra little layer. Sometimes they get mad if you print A. Let's see that. Oh, input output error. Doesn't like that. Okay, I'm gonna try and run your thing.
Okay.
Save as code.py on the CircuitPython board. Mine is still just blinking its little dual thing. I'm gonna replace it and we're gonna save it. And this also says input output error for me. Wait, you gonna do it? You gonna
I
do
just
it?
noticed something.
What's that?
This is a Raspberry Pi Pico W.
Oh, I mean
Is
that seems
yours?
like it should be compatible. Mine's a regular one. I actually had a PicoW and I lost it somewhere in my move over the past year. So it is printing. No, it's doing the thing. It's doing the thing. Oh my god, look at it.
Okay.
So this is a
All
regular.
right.
This is a Pico 2. Yes.
The
That's
Pico
so
2 is working with this code? Okay, forget
oh
the
my god.
Pico W. Okay.
I'm so
All right, all
excited.
right,
We
all
got
right.
to do the thing.
So that's just my code, but
It took
then
our
you
entire
added the
hour. Wait, you
variable,
have a
or
thing,
was it
like
working?
a live show at your office that you're in, like right now. I will say.
A live
So
show?
why don't you try and get this
What?
running, and then like if you gotta go, you gotta go. But like I am so excited, we actually got there.
Oh no, yeah, yeah. Let me try
We
it.
gotta
Let me try my Pico
go.
2. Okay, my LED is blinking.
And we're gonna share this code
Okay.
in
First of all,
a
I
getting to
just need to
Blinky
say
because
it's
so that
already
you don't
working
have to
before
do
I've even
this.
put any code on it.
What you got? This is so it's on
It's
solid,
already
right?
working before I've put any code on it. Yes,
Well,
so this is the
working as
old
in like
code
it's got
finally running and finally working.
maybe we had to reset it. No, that doesn't make sense
This
because I
never
didn't have to
happened
reset it to get.
before. No, but the
Yeah,
REPL was showing the code running.
yeah.
So
The
I
rebel was
couldn't get
showing
an
the code
LED
running,
to
and we
come
never
on.
like I didn't have to hit
Yeah.
reset or anything. Well,
I couldn't get an LED to come on this thing, and now I just plug it in, and the code that was on there before that was just turn the LED on is now running perfectly. So I
it's
didn't
because it
even
knows that
try
you
my
have to
new
leave.
code.
It's like
What's that?
David has to go. I'm gonna mess with him now. It's
It's
gonna live in
yeah.
your.
No, I mean, let's
You're
keep
gonna be
going.
watching that live show, and you're gonna be like, it's got you.
Now let's just look at the code. I know it's already open, but I just want to see. I just want to just understand what's happened here real quick. So if I open code.py, it's just going to be that turn it on and stay on.
You
Okay.
gotta copy
So
it. Keep
this
it
is the
safe
code.
somewhere.
This is the code, and it's working fine.
Which one is it? The original example we were looking at?
It's the original
It just turns it
just turn
on.
on the LED example, and it's working fine. And all I did was
That's
unplug and replug
infuriating.
the thing. So now, if I save this file, is it going to start blinking, or do I have to like unplug it and replug it in? And
I'm gonna
okay,
focus on you.
everything's working great. Everything's working. It's all normal. Everything's
It's
fine.
blinking.
So why didn't it work before?
Oh, that's the most infuriating. There's a question of why doesn't it work, which is infuriating, and then there's the even more infuriating question of like why does it work now? I'm gonna
Wow.
do a bunch more experimentation. We're gonna put up a tutorial on this. Everyone, I'm gonna put you on the tutorial too because you got a Hackster account. Yeah, check in the links in the description for the upcoming tutorial, which will go live on both of our Hackster profiles, and I'll
And
put a little feature on it. I might do a video as well next week, but
is
we'll
the
figure out why
tutorial
this
going
is
to be
happening.
called? Is the tutorial going to be called "How to Blink an LED in just over an hour"?
Yes. I'm not gonna. Well, no, I'll include a brief mention. Like I'll link to this video if people want to see the like horrible process by which we arrived at this hard-won victory. But I'll put the explanation very quickly and legibly so that people can see it getting
Maybe
started.
just edit the video down to "Hi, welcome to the video," and it's blinking, yay! And we can just skip the 58 minutes between that.
Basically what happened, right? Anyway, everyone, I really hope you've enjoyed hanging out with us. Thank you for joining us and dropping your comments in and commiserating with us on this ridiculous adventure. I think this is really fun, and it really shows, we've been doing stuff with microcontrollers for a bajillion years. I was not, officially like formally trained in any of this. I majored in Spanish. I don't know about you, David, but like,
I have an honors degree in computer science from the University of Michigan, so I don't know what my problem is.
But this is all, there's always stuff to learn, and it's always possible for there to be like little things along the way. This is normal. If you go through this, it's normal. No matter how many times you've like done an Arduino thing, it's normal. And you always kind of gotta deal with weird little snafus and get up to speed on stuff that you haven't learned about and whatever, or touched it in a while. So thanks for joining us on this adventure. Stay tuned for the Getting Started project on Hackster, and hack on. Yeah. Thanks again, David. This has been awesome.
Thanks for having me.
Cheers. Happy weekend, everybody.